So page 353, again, this is 11.2. We're talking about the speed of sound in air and how much time is required for sound to travel 1.4 kilometers through air if the temperature is 30 degrees. Well, you remember the formula, right? The speed of sound in air is 332 plus 0.6 times the temperature. So that formula you need to memorize. We have the song there. It might be still stuck in your head from yesterday. I'm not really sure. But anyways, we are asked for the time, okay, when, how much time is required for the sound to travel 1.4 kilometers through air if the temperature is 30 degrees. Thank you. So this formula, this 332 is what? Meters per second. So we could find the speed, first of all, in meters per second given the temperature. So you're going to want to find whatever you can. And in this case, we could plug the temperature in and find the speed. If we have the speed, we could use distance, right, to find time. So let's find speed. So the speed of sound at this temperature looks like this. And the temperature is 30 degrees. We put 30 right there. And so you get on your calculator and you go 332 plus 0.6 times the temperature, which is 30. And that should be 350. Okay? So the speed is 350 what? Meters per second. Okay, so we're getting close. We have a speed, but now we need a time. So how are speed and time related? Well, speed equals distance over time. Right? Speed equals distance over time. So here's the time I'm looking for, and I'm given a speed, so I could, and I'm also given a distance. So I've got this, and I've got this, and I can find time. The only issue is our units are not lining up so far, right? And why is that? Because the speed, and I'll just keep going down here, the speed is in meters per second, right? The distance is in kilometers. So that's no good. That's no good. Our distance units have to line up. What's the quick and easy way to fix that? What should I convert? What's the easiest to convert? It doesn't matter. How would you make those the same? Okay, change the distance here that's in kilometers to meters. That's what I would do for sure. So 1.4 kilometers is 1,400 meters. Very good. Okay. So now we don't have to worry about the units. So let's just get them out of the way and just make this simple little equation. And I cross multiply and I divide. And so I end up with T equals 1,400 divided by 350. And this time is going to be in what units? That's right. That's right, because we have meters and the speed was in seconds. So 1,400 divided by 350 is 4. So the time is 4, and that's 4 seconds. So does that line up with what you guys had there for number 2? Yeah? Okay, 4 seconds. Does that help? Whoever asked about that? You guys? Yeah? Okay. Okay. All right, any other of those 4 questions? I did have a question yesterday. Sorry, someone going to say something? I did have a question yesterday about number 1 here, I think, in 11.3, Mach number. So remember, Mach number is the speed of the object divided by the speed of sound, and it's right above there. Okay, it's right here. And the speed of the object is in kilometers per hour here. And so it would be nice to figure out what the speed of sound is in either kilometers per hour, or we change this to meters per second, right? So we have to kind of do some adjustment. And if you remember yesterday, meters per second to get to kilometers per hour, do you remember we did this yesterday? What did we end up multiplying by? Do you remember what that number was? Close, 3.6. Did you say 2 or 3? Oh, you said 3? Okay. Sounded like 2. Sorry. 3.6 is correct. Very good. So whatever your number is, you multiply by 3.6 to get kilometers per hour. Or whatever your kilometers per hour is, you divide by 3.6 to get meters per second. So 3.6 is our conversion factor. All right. So let's do 1A. Let's do 1A together. What's the Mach number of an aircraft traveling at sea level at 0 degrees with a speed of? Okay, well, at 0 degrees, right, 0 degrees Celsius, the speed is 332 meters per second. Okay? Now, if I multiplied that by 3.6, what would I get? 332 times 3.6. That would give me 1195.2, 1195.2, and that's going to be kilometers per hour. All right? So, I've got 1,400 kilometers per hour. That's the speed of the object. Here's the speed of sound. So, in order to get Mach number, all I do is use those two. So I'm going to change pens here. Mach number is speed of the object, 1440 kilometers per hour, divided by the speed of sound, which we just calculated to be 1195.2 kilometers per hour. And so 1440 divided by the answer that we just got is 1.2. So did anyone get 1.2 for a Mach number for 1A? Mach 1.2. So that makes sense, right? We are 1.2 factor above the speed of sound. So 1440, 1400, 1100, right? 1.2 times. Okay. Okay, any other questions there? Again, you should have the answers to these questions in the back of your book so that you can check them, and I will leave that to you. So no other questions?